Thank you guys for the flexibility. So we have the Cure Day of Science is right after this, and we want to invite you all to join us, but that means that when the timing got off, it would make me late. So we switched order. Thank you so much. And so I'm Tracy Dixon Salazar, and I'm Associate Research Director at Cure. I'm also a mother of a child with epilepsy, and so I'm going to talk about not my story, but her story, and I have the honor of having her in the back with me today, my daughter Savannah, beautiful girl. So I'm going to talk about her, and then also about the Education Enrichment Program that Cure has just started. So thank you guys for joining us. So our introduction into the world of epilepsy was pretty harsh, as everybody's. You're introduced pretty much by seeing a loved one have a seizure. But before she had her first seizure, she was typically developing. I was a young mom. I think I was 21 years old when she was born. And I had 2 kids, and I was staying at home, and I was raising them, and she was doing beautifully. And then at the age of 2.5, this is what we witnessed when we came into her room when she was 2, and she was shaking and gagging, and we didn't know what we had just seen was a tonic-clonic seizure. And that quickly escalated into other seizure types, as you're seeing here. A myoclonic jerk was what you just saw. This is an atypical absence seizure with some myoclonic seizures, and then our atypical absence again. And so what started out as a single seizure when she was 2 quickly developed into multiple seizure types. And we got in to see a doctor, and they didn't want to call them seizures. They called them spells or episodes because they didn't want to label her with this horrible diagnosis. So that was our second introduction into the world of epilepsy. And it actually took them 2.5 years to officially diagnose her with Lennox-Gastaut syndrome. And so over the course of the years, we saw Savannah go from this vibrant, healthy, beautiful child to one that was distant and fading and sleeping all of the time and seizing every single day. And at the highest dose point in her life, she was on 7 different medications. Those are shown here. And at that point, I think for all the parents in the room, you know that you're experimenting. I mean, there are no experiments that tell you how these 7 drugs work together to help your child. And yet she was still seizing. And she wasn't the only one that was on medication. These were my chosen medications, Tums and chocolate, but also antidepressants and counseling and just help, because our normal lives turned completely abnormal by daily seizures. You didn't know if you were going to be at work. You didn't know if you were going to be in the hospital. You didn't know if your child was going to be alive. And so her epilepsy was horrifically, horrifically devastating. And so as a young mother, I began to immerse myself in the literature and the research that was out there. And I started to learn things like epilepsy is a spectrum disorder. Some people are doing pretty well and don't have that many seizures, and some people are awful and have horrific seizures and daily seizures like our Savannah did. I learned that it affects 1% of the population, 3 million Americans. 1 in 26 will develop it in their lifetime. And that more than half of the cases begin under the age of 15 years old. And that between 33 and 45% don't respond to any of the more than 40 therapies that we have on the market now for epilepsy. So we get all these new drugs that come out, but we're not seeming to make a dent in the most severe, like the Savannahs out there. One statistic that really bothered me was a statistic here is that 70% of people with epilepsy don't know the cause or didn't know the cause. And this was a statistic that was given in an unappalled sort of way. And so I was always struck at how appalling it was to me and how not appalling it was to somebody who'd been in the epilepsy space for a long time. And then I learned that the cost of epilepsy to countries like the US and other industrial countries was huge. It cost $22.6 billion a year in indirect and direct costs. And most of that cost is concentrated in kids like our Savannah, who can't work, who are on Social Security, who are in the hospital all of the time, and who also die prematurely in many, many cases. And this is something that really struck me as a mother of a child who is very sick. It's like, why? Why is it so common? And do I feel like the only person in the world that's going through what I'm going through? We learned that research funding lags desperately behind. So for being a very common disease, we are dramatically underfunded in the epilepsy research space. We are 10 times more common than Parkinson's, and we receive 6 times less funding. And so it's a disease with a lot of misconceptions and misunderstandings, and I just couldn't understand why. So I started going to college, and I spent many, many years doing research and doing research in the lab, and fell in love with genetics. So I think most of you guys at this point have heard about genetics and DNA and how many, many genes are being identified for epilepsy. And so to think that your uniqueness, whether it's an amazing trait in you or a severe trait like something like epilepsy in our daughter, could be the result of changes in the letter code of the DNA in your cells is just fantastic and phenomenal to me. And I was drawn to this sort of research. And it was at this point that I decided that I really wanted to be a part of the researchers out there that were trying to help the next generation of Savannahs. The next mother who had a child who was healthy and then developed Lennox-Gastaut shouldn't feel so alone and so devastated. And we certainly should make a dent in that 70% unknown cause number. So I became a part of the team of people that were looking for genes that caused epilepsy. And I'm happy to say that we've had some success in that area as scientists. So the first gene for epilepsy was identified in the mid-90s, and we now are tracking to more than 300 genes that are involved in epilepsy. And some of these will be genes like the Dravet syndrome gene, right, like SCN1A or other genes, CDKL5, but some of them will be syndromic genes like lissencephaly genes or the lysosomal storage genes. If you have epilepsy, you are on our list, your gene is. And so what we're really focusing on, what I was really focusing on in the genetic space, was identifying the causes of epilepsy and then getting patients connected with each other and driving research forward that can target treatments to those genetic causes of epilepsy. I mean, with our own child who was home and experiencing so many seizures. So by the time she was 18 years old, she had had more than 40,000 seizures. The time to diagnosis was 3 years. She had seen at least 7 different doctors, but she had tried and failed 26 therapies. And so we were at a point, she tried everything from diets to devices to drugs to alternative therapies. And so by the time I got into the research base in genetics, I was really focused on finding the cause and then targeting treatments for that. And so that's really been our focus. And so I was ultimately able to finish my degree. It took 12 long years, was a C student in high school, and got a PhD in neurobiology. And there's Savannah, right there, my biggest fan. And I still, at that time, really thought that I wanted to help the next generation of Savannahs. You know, we're finding causes, and they're going to get connected to their cause, and it's going to be amazing. And meanwhile, she was at home still suffering and still struggling. When I was doing my postdoc, I think this was my 13th year in the research lab, I was doing my postdoc, and the technology of sequencing somebody's, all 20,000 of a person's genes had just become commercially available, and this is what I was doing in the lab. And so the person I was working for had said, you know, we should really sequence Savannah's DNA and see if we can find a cause. And so we did that, and it was my job to do that in the lab. And so we sequenced her DNA, we analyzed it. She didn't have any mutations in any of the 300 genes. And so I did what I now have come to affectionately call the crazy mother analysis, where I grouped her genetic defects into pathways. And we found that Savannah actually had quite a few mutations in calcium signaling genes. So these are calcium channels not previously linked to epilepsy. Here's a picture, a little schematic of a calcium channel gene, and each of those red dots represents where she has a mutation in her genes that's predicted to be function changing for that. And for those of you who don't know, calcium channels are very important in neural signaling for allowing calcium to come in and pass the signal from the neuron on the front end to the neuron on the back end and then carry that signal along. And what it looked like from her genetic mutations was that she was getting too much calcium being fed into her neuron. She had what we call gain of function calcium signaling pathway dysfunction. And so we analyzed the data, we went back to the lab, we did research on some of these variants and showed that she has gain of function calcium channel mutations. And thankfully for us, we were very lucky. Most of her mutations were in a specific type of calcium channel called an L-type channel. And there's a drug on the market that's used for patients that have high blood pressure and also arrhythmias called verapamil. And it's a drug that, if used in a patient who has too little calcium going into their cells, could actually be quite severe and serious for them. But in Savannah's case, the prediction was that she had too much calcium going in. So we tried her on this drug when she was 18 years old. And at that time, she was seizing every day. She was having about 300 seizures a month. She was going into non-convulsive status every week, at least once a week, sometimes 3 times a week. When we were lucky, the diastat would work, and it would stop the seizures, which would give it rectally. And if it didn't work, we would go to the hospital where they would proceed to give her more medication and then considered putting her into a medically induced coma to stop the seizures. And our lives had been like that for at least 5 years prior to the treatment of this. So we put her on verapamil, and within a week and a half, the status completely stopped, and her seizures went from 300 a month to less than 20. And for the last 6 years, she has had a 95% decrease in her seizure number. She's not seizure-free, but she's had a 95% reduction. No other drug has done this. And she does not go into status anymore unless we forget her medication. Dead. Shame on you. So it's a 100% reduction in her status. And here's a child who sees for 16 years completely uncontrollably. And we went and we took a look, albeit in a desperate mother way, but at her genetic makeup, and found a drug that we could target to that. And I think it speaks to the potential of something we all are familiar with now, is precision medicine in epilepsy, finding the underlying cause and targeting therapy specifically to those causes. So Savannah was 18 years old when we put her on verapamil. She is 23 years old now. And for the first time, she is living life since she was 2. And we are getting to know the child that we never got to know, who used to sleep 17 hours a day and couldn't really get her words out and talk. She's come off 3 of her medications, and it continues to wean very, very slowly. She's bossy and sassy and demanding and silly, and she is learning again for the first time things like putting your seatbelt on, or, you know, a preference, what she wants, what she doesn't want. And you know, she's playing in the Special Olympics for the first time ever, and she is living life, which is not something that she did before. And so while she's not seizure-free, and she continues to suffer the lifelong consequences of epilepsy, there's a part of me that constantly wonders, what if we had found this when she was 3, right? And so that's my dream. That is my dream, is this idea of precision medicine and epilepsy. And it wasn't planned initially, but it's this idea that we can take the population of people with epilepsy and we can stratify them, whether it's by a gene or it's some other molecular cue, and then we can match them to the perfect medication. And not only that, but we can keep them away from the medications that are going to hurt them, like we just heard about in the talk before this. And so that is something that all started with a little girl who had horrible epilepsy, who inspired me to do something amazing and to grow and to find this treatment in her. And since then, I've come to work at Cure, and we're trying to do this more broadly for people around the world. So we've created at Cure a program called the Epilepsy Genetics Initiative, and it's the beginning steps of our way of pioneering precision medicine in epilepsy. So in order to get to precision medicine, this idea that you get a diagnosis and you get the right drug at the right time, you have to get a diagnosis. And so that's what EGI is all about. This is a database where if you have had genetic testing done, a testing called exome sequencing, your data can be deposited into EGI, and we will analyze and reanalyze the data for you. A huge percentage of patients who have this testing done get an unknown cause of epilepsy reported back, or nothing. We don't know. And so our job is to reanalyze the data. And with the rate of gene discovery and variant discovery in epilepsy, it's crucial to reanalyze the genetic data. If we find something, it will be reported back to the treating physician, who can then plug you in. You now have a diagnosis, a genetic diagnosis. And what we're finding in the kids like Savannah, in the severest of kids with pediatric onset, drug non-responsive epilepsy, 40 to 50% of them have a gene that is driving their epilepsy. These are our sickest of kids. And so we have the real potential to make an impact. These kids that aren't responding to any therapies now. So we will reanalyze the data. If we find anything, we'll report it back to the treating physician. We will plug you in if you have a genetic mutation in this gene or that gene with the community of patients and researchers that are out there. And then if you want, you can make your data available for research as well, because there's so much research that we need to do. And so we would love to talk to you, all of us at Cure, more about the Epilepsy Genetics Initiative. And so all because of one child and one parent who got a degree, we now have this initiative and this program. And we have another one that we're going to talk about right now that's really absolutely fantastic as well. This is our Education Enrichment Fund. This is with Cure. This is brand new, and we can talk about it a little bit more. So through the generous support of Beck, who is here, and they're going to come up and talk in just a second, Cure created the Education Enrichment Fund. It is a scholarship program for people with epilepsy or their loved ones or caregivers, anybody in the family. And this scholarship awards a one-time award of up to $5,000 for anything from going back to school, like I did, to improving your ability to be a better caregiver, to be a better advocate, to be a better a person in the epilepsy space that wants to make a difference. So Beck has been a really great partner in this program, and it feels like they're in the trenches with a lot of the families, as we're going through the day in and day out with our kids. So thank you. And the scholarship is so exciting because I got to be on the committee of people that reviewed the application. So we did a small pilot with the Education Enrichment Fund with the Lundbeck folks, and we had a group of patients and parents and people connected to epilepsy to review the grant. So we put this out to our Cure crew and the volunteers at Cure just to see how the program would work, get it up and running. And we got a really competitive pool of applications and decided on 3 scholarships for this year. And one of them went to a mother who, like me, just didn't sit back and take no for an answer, identified the genetic cause of epilepsy in her child, and started a foundation specifically around that gene. And now this mom works to connect families and then to try to drive research. And so she's going to be using the scholarship to learn how to write grants and to do a better job of advocating and to build her foundation and to do more support as she moves towards this precision medicine for her genetic epilepsy. Our second scholarship recipient was a sister of a brother with really severe epilepsy. And she had just watched the devastation over the years and developed such a compassionate heart, as so many of us have seen in our other children or in loved ones of kids who have very severe disease. And so she is using her scholarship to go back to school. She's getting a master's in education and is going to be educating the most severely handicapped kids because she believes that they still can learn and hasn't given up. So just so moving. And then the third scholarship went to a woman who has epilepsy. She developed epilepsy as an adult. And she has really overcome all of the challenges and misunderstandings and miscommunications and misconceptions about epilepsy and the discrimination that occurs. And she has a family and she has a career that she fights for every day. And she is now going back to school to get her master's in public health because she wants to do more advocacy efforts. And so that is how she's going to use her scholarship. And in December of 2016, Cure will be launching the EEF Scholarship Fund nationally in the U.S., so anyone in this room could apply. We hope you'll spread the word, and we'll happily tell you guys all about it. There's a brochure. For anyone who has a dream like I did, and whether that dream is, I want to go back and get a PhD because I want to make a difference in my child, or I have epilepsy, or I'm a caretaker and I need to learn first aid. It doesn't matter what it is because we want to support you in that. So So that's it. I really hope you guys will come and talk with us. We will all be in the Day of Science upstairs, which starts in a few minutes, I believe. This is a Cure Day of Science where we'll have scientists. I will be one of them, put on my science hat, talking about 4 topics: traumatic brain injury, CBD, CBD-rich marijuana, and epilepsy. We'll be talking about genetics, my favorite topic, as you might have learned. And we will be talking about devices. And so we hope you guys will come up, and we can also talk to you more about the amazing Education Enrichment Fund. Our good friends from Lundbeck will be there, and my daughter will be there. You guys can meet her. And with that, I will just stop and see if you guys have any questions. Yes?
You talked about doing the genetic sequencing. What was the specific type of sequencing you want?
It's called...
Getting?
Yeah, so the question is called, what's the genetic testing that we're using for EGI, our genetics initiative? And I do hope you guys will, here's the website for the EGI link here. It's called Exome, E-X-O-M-E. And what it is it sequences all 20,000 of your genes at one time, approximately 20,000. There are other types of tests. There are panel tests. There's tests that look for deletions and duplications in genes, which are important. The reason we're doing exomes is because of the research part of EGI. And so if you have all of the DNA, you can start to pick up deletions, duplications in that. One day we want to do genomes. And so if we have some materials on our table that can help you to talk to your doctor about getting the testing, but you will order the testing through your doctor. And if you email us or call us or visit our website, you can learn more.
Do you know what the cost is approximately?
Yeah, so each of the companies will work with you individually depending on what type of insurance you have and whether or not you've met your deductible that year. Just straight out of pocket, it's $7,000 to $10,000, but most of them can get it down pretty low depending on your insurance. Medicare, Medicaid, Medi-Cal don't cover it at all, and so anybody that doesn't have that type of insurance, it's a problem. And so we're trying to work with people. And if you have insurance and it's denied, we can help you. We have letters and information that you can provide to your doctor and your insurance company.
Thank you.
Another question? Yes.
I have TLE, but for years, so I was about 30, that a doctor came up with an idea of how, what happened, and he thought it was a brain trauma. But could genetics be
That's a great question. Yeah, so people start saying Tracy thinks everything's genetic. It is, yeah. So she has temporal lobe epilepsy, and she's wondering if it is genetic. And so the answer is your genetics are certainly determining how you are responding to whatever's causing, right? So how you respond to medication. In some patients, the traumatic brain injury could be, or the temporal lobe epilepsy could be from an injury, right, that you sustained during birth and you didn't know. But scientists have also shown that, so just because an epilepsy is genetic does not mean it's inherited anymore. So you can actually have a mutation that occurs after the sperm and egg come together inside the womb. And so you didn't get it from mom or dad, but the spontaneous genetic mutation occurred. It's called a de novo mutation. And so scientists have now shown that there are some patients that have focal epilepsy where the mutation just occurs in the region of the brain that is abnormal. So whether or not your TLE is genetic or not is a really tough question to answer. But scientists are really trying to hammer out the problem specifically and determine how many people with focal epilepsy, how many people with malformations, how many people with injury have a genetic component to their epilepsy. And so since your DNA regulates everything that happens in your cells, there are interactions, but how strong are they, and is there anything we can do about them is a real question. It's a great question. Yeah. One more question, and then I'll certainly be available for questions after. One more? Yeah.
So, I have a question about crazy mom analysis.
Crazy mom analysis.
So, did you go through your entire result file? Question one, how did you get it? Two, did you go through and group them on your own, all the variants and elements?
Yeah. So I went to our entire results file. So when you get back an exome sequence, you get about 1 million variants. And this was back before we had the pathway, the pipelines worked out. So this was all in Excel. And so 1 million variants, genetic variants in Excel, and then crossing them through the various services. So we were setting up the pipeline efficiently. So yes, I did analyze it by hand. And then by doing all of the bioinformation analysis, we were able to narrow it down to 300 variants that were unique to her, predicted to be damaging, not found in the populations that we had at the time, and also predicted to be somewhat function changing in her. And those are the ones I grouped. And there were actually a number of tools available that are still available today, where you can actually group variants into functional signaling pathways and figure out how that they work. And it was all done by hand. So what I will say so the way I got the data was that I was the scientist that generated the data. But your data is available to you today. So if you haven't done a genetic testing company, you can request a copy of your data. There are actually now cloud-based systems where you can put it in the cloud, and there are systems that will help you to analyze it in the cloud now. One that comes to mind is one that's run by researchers called MyGene2, but there are a number of others where you just put it in this, and then you can analyze it. You have to agree to participate, in research, to a degree. You get to determine how much research you want to participate in. And then I think the analysis for clustering, I think it will come. I think scientists will get there. But right now, we're still trying to figure out what the approximately 20,000 genes do, right? And trying to figure out how they work together is really tough. But it's really complex. So there have been instances where two genetic mutations together that independently cause epilepsy together in an animal will make the epilepsy go away, right? Or you'll have somebody who will have an epilepsy gene driving their epilepsy, but maybe there's another gene in there that will somehow make their epilepsy less severe. I mean, look at Dravet syndrome, which I think is the most well-known genetic epilepsy. What these kids look like is so different, but they might have the same actual mutation, and a lot of that has to do with other genes. So it's a great question. All right, with that, I thank you so much for letting me go. We're going to head up to the Day of Science. We hope you will join us, and thank you guys for having me.